Thank you, Bad, for inviting me to do a webinar about chronic fatigue syndrome and ME. And what we're going to talk about is the biological basis for the treatment of chronic fatigue syndrome and ME. Now, don't worry if you don't remember every last detail, because it's detailed in my book, The Diagnosis and Treatment of Chronic Fatigue Syndrome and Myalgic Encephalitis, The Roadmap to Recovery. This is from chapter 2. Now, the point here is that fatigue is the symptom we experience when energy demand exceeds energy delivery. When you think about it, that's absolutely obvious. And a quote that I often give my patients, which makes this very memorable, is the Mr. McCorber quote from David Copperfield, where he states, annual income, £20, expenditure, £19, result, happiness. Income, £20, expenditure, £21, result, misery. And so it is with energy. We have to keep our energy expenditure within energy demand. Okay, so what that means is that with anybody with a chronic fatigue syndrome, there are two sides of the equation: how we're earning energy and how we're spending it. Now, in thinking of energy delivery in the body, a very useful analogy is to think of the body as a car. And I use this analogy all the time with my patients because it allows them to get their head around what I'm saying and put the right organs in the right department. And the engine of that car are our mitochondria. And mitochondria are organelles which are common to all living cells in the whole animal kingdom and indeed the plant kingdom. They are essential for creating energy for the cell. If you can't create energy for a cell, it's dead. The fuel that goes in that car has to be the right sort of fuel, and that is very much dependent, of course, on diet and gut function. And these are the two subjects we're going to talk about today. Other issues, of course, are equally important. I talk a lot about the thyroid gland, which is the accelerator pedal, the adrenal gland, which is the gearbox. Sleep is all about service and repair. So when it comes to energy expenditure in the body, about 2/3 of all energy expenditure goes on just staying alive, and that's what we call the basal metabolic rate. So just keeping the heart going, the brain going, the gut keeping warm, normal immune function, that's basal metabolism. That leaves us with 1/3 of energy to spend mentally, physically, and of course the reason why we're alive, reproduction. The two common holes in the energy bucket are the emotional hole and the immunological hole. And for my ME patients, this is often a major problem. Many cases of chronic fatigue syndrome have an infectious trigger, and the immunological hole embraces not just chronic infection, but allergy and autoimmunity. So what this means is that chronic fatigue syndrome just reflects poor energy delivery mechanisms. Myalgic encephalitis is chronic fatigue syndrome plus inflammation, i.e. the immune system is busy. So fatigue is an essential symptom to maintain life. And without the symptom of fatigue, we would all be dead in 11 days. Nobody has survived that long without sleep. So we all suffer from fatigue. It's a universal symptom. It's a very powerful symptom. It stops athletes winning gold medals. And fatigue is the clinical picture that arises when energy demand exceeds energy delivery. Now, that's not strictly accurate. If energy demand exceeded energy delivery, we would be dead. So it's when that gap narrows. The body has to protect energy delivery mechanisms for obvious reasons. So diagnosis is all about identifying the reasons for those things, because that gives us very clear indications for management. So we have to ask the two questions. Is our energy pot too small, i.e. are we generating energy efficiently, or are there wasteful holes, i.e. are we wasting energy or spending it without good cause? All good history taking starts with symptoms, and patients often come with a shopping list of symptoms, but these are the symptoms that particularly pertain to poor energy delivery mechanisms, i.e. when energy demand exceeds energy delivery or gets close to, rather. So physical fatigue, so very poor stamina and post-exertional malaise, i.e. delayed fatigue. And this is what characterizes chronic fatigue syndrome patients from normal fatigue. At the end of the day, yes, I'm normally tired, but I have recovered by the next day after a good night's sleep. If, however, your fatigue spills over to the next day, and that is associated with the post-exertional malaise, i.e. you feel ill, then you're starting to slip into chronic fatigue syndrome, or ME. Mental fatigue, the brain is enormously demanding of energy, and without good energy delivery, the brain will go slow. Poor concentration, can't problem solve, cannot concentrate, short-term memory is very poor, and many other mental symptoms. Dizzy spells and feeling faint, that's effectively a very early symptom of postural orthostatic tachycardia syndrome, or POTS. The point here being is that it's much easier to pump blood when the body is horizontal, when it's lying down. When it stands up, it has to increase cardiac output by about 20%. And for some people, they don't have the energy delivery mechanisms to allow that to happen. And the result of that is when they stand up, their blood pressure drops, their pulse races to try to compensate for that. But the upshot is if the blood pressure drops sufficiently, they will feel dizzy and faint and maybe go unconscious. Feeling stressed. I think the symptom of stress is what the brain perceives when it knows it doesn't have the energy to deal with demand. If people have got plenty of energy, nothing upsets them because they know they have the mental, the physical, the emotional stress to deal with that. If you don't have those energy resources, then the sensation of stress results. Low mood and anxiety. Again, that's another way that the brain stops the body from spending energy. If you're depressed, you don't want to do anything. You procrastinate, you prevaricate, you don't get around to doing things. Loss of muscle power. Obviously, muscles are greatly demanding of energy. Muscle pain, because if mitochondria aren't functioning well, then there is an early switch into anaerobic metabolism, and that produces lactic acid, and lactic acid is painful. Variable blurred vision is another common symptom because the muscles of the eye fatigue in exactly the same way as other muscles do. If the muscles of the eye fatigue, the lens goes out of shape and vision is blurred. So, symptoms of ME. ME is chronic fatigue syndrome plus inflammation. So we have all the chronic fatigue syndrome symptoms plus inflammation. And that is characterized by the cardinal symptoms of pain, swelling, heat, redness, and loss of function. And of course, any organ in the body can be affected by that. This occurs when the immune system is activated, and that can be for reasons of infection, which might be chronic low-grade infection, allergy, or autoimmunity. So in ME, we are seeing poor energy delivery symptoms, which I've just detailed, plus inflammation symptoms. Now, for the purposes of this webinar, we're going to concentrate on mitochondria, i.e. the engine of our car, and fuel. And if you think that's a bit limited, I can assure you I spend more time talking about these two subjects than all other subjects put together. And again, as I get older and perhaps wiser, although I have to say my daughters doubt that very much, what I find is that the basic things done really well get you an awful long way there. Mitochondria are the engine of our cars, and they make up a large proportion of the body. Some figures suggest up to 40% of the cell's mass, possibly 10% of the total body weight. We have some 10 million billion mitochondria. So each cell of the body every cell of the body has mitochondria. The busier the cell, the more mitochondria it has. So a heart cell, for example, will have maybe 2,000 or 3,000 mitochondria contained within each cell. And for those mitochondria to work efficiently, they need the correct fuel and they need oxygen. And essentially, they burn fuel, which comes in the form of acetate groups. They burn that in the presence of oxygen to make a form of energy that the body can use, and that is ATP, adenosine triphosphate. Now, aerobic metabolism is incredibly efficient, and from one molecule of glucose, you can make at least 30, possibly 36 molecules of ATP, depending on how efficiently the mitochondria are working. By contrast, if you are burning sugar anaerobically without oxygen, you can only make 2 molecules. So this is why oxidative phosphorylation is such an important biochemical tool. Essentially, so this just gives us an outline of how it works. So we have the mitochondria in the middle, we have fuel coming in, we have oxygen coming in, it's burnt, and that generates ATP, which is the energy molecule. Outside the mitochondria and in the cell, that gets converted to ADP, releases a hit of energy, and the cell can use that energy in order to do work. Then ADP is recycled back into the mitochondria. That's what should happen in normal energy production. Now, ATP is the currency of energy. And with ATP, the cells can do any job of work. They can conduct a nerve impulse, they can contract a muscle, they can synthesize a protein. It's a fundamental currency of energy molecule. But if ATP production is slow, then the cells will go slow. And chronic fatigue syndrome is characterized by slow production and slow recycling of ATP. And the clinical picture that results is one of chronic fatigue syndrome, i.e. very poor stamina. And when you think that it takes about 10 seconds for a molecule of ATP to complete that whole cycle, i.e. to be formed in the mitochondria, to pass out into the cell cytosol, to release its energy to the cell, and to be recycled back into the mitochondria, that takes 10 seconds. What that tells us is that many chronic fatigue syndrome patients can last about 10 seconds before they run out of energy. Now, what happens when you stress the system? And by that I mean we ask for energy out of mitochondria faster than mitochondria can supply it. Now, normally ATP, which is the triphosphate, is all converted to ADP, which is the diphosphate, and that is recycled. But if ADP builds up because it can't be recycled or it's recycled slowly, some of it will get shunted into AMP, which is the monophosphate. Now, although in the short term that will deliver the cell with a little hit of energy, in the long term this is absolute disaster because AMP cannot be recycled. Effectively, it's lost to the system. Energy supply can be dramatically shut down and the sufferer feels completely polarized. Now, this creates the first major symptom that we see in chronic fatigue syndrome, namely very poor stamina. Because AMP cannot be recycled, the body has to make brand new ATP. Now, this it can do from the 5-carbon sugar called D-ribose, and there's a nasty bit of biochemistry that does that, that's called the pentose phosphate shunt, but it's difficult, it's slow, it takes some days. And this is what results in delayed fatigue. In the interim, the body can cheat, it can make tiny amounts of ATP anaerobically from glycolysis, but as we discussed, you can only get 2 molecules of ATP from 1 molecule of glucose. And the problem with that is you also create lactic acid, and that causes pain. Now, the next slide gives us an idea of how mitochondria work. And essentially, what they are doing is they are pumping protons across mitochondrial membranes. And they do that with a series of enzymes called complex 1, 2, 3, and 4. And they pump hydrogen ions or protons outside until you get a proton gradient, and then complex 5 suddenly allows all those protons to come rushing through like an HEP, hydroelectric power station, and with the bolt of energy that generates, it can convert ADP into ATP. So that's how that works. They don't spend too much time on that, it's jolly difficult. But the next slide gives the symptoms that we see in genetic mitochondrial disease. Now, look at these complex 1, 2, 3, 4, etc. dysfunctions. What do we see? We see all the symptoms that I see in patients with chronic fatigue syndrome. Exercise intolerance, muscle wasting possibly, lactic acidosis, cardiomyopathy, and in children, of course, poor growth, loss of power, organ failures, mental confusions, metabolic acidosis, all those symptoms. So that's what we know exists in genetic mitochondrial disease, but essentially ME is an acquired mitochondrial disease, and we see many of those symptoms in patients with acquired mitochondrial disease. So having established the hypothesis that mitochondria are centrally involved in chronic fatigue syndrome, I wanted to do a test. Now, I've been working with Dr. John McLaren-Howard for all 30 years, looking at tests for patients who have all sorts of illnesses. And I have to say, he is the most brilliant biochemist. He should be awarded the Nobel Prize for Biochemistry, in my view, because he comes up with new tests that are clinically relevant. And what I wanted John to do was to put together a test for mitochondrial function. And going on to the next slide, this is what he did. And these issues that you can see here, he can measure with his testing. So we're essentially looking at how efficiently mitochondria work. We're looking at the rate at which they convert ADP to ATP. We're looking at how efficiently ATP gets from the mitochondria into the cell where it's needed, how well ATP releases energy, and that's a magnesium-dependent process, and then how efficiently ADP gets shunted back into mitochondria. This is the sort of report that he comes up with. I'm not going to go through that now. Let's go through that into the next slide. So what this test tells us is it tells us how much ATP is present in the cell and how efficiently it can give up its energy to form ADP, and that's a magnesium-dependent process. The test tells us how efficiently mitochondria can synthesize ATP, i.e. the rate of oxidative phosphorylation. And the test tells us how efficiently mitochondria can move ATP from the mitochondria into the cell where it's needed and recycle ADP back from the cell into the mitochondria again. Now, the point about all those measurements is that we can calculate a mitochondrial function score from that, because if any one of those processes is going slow, then energy supply to the cell will be inhibited. So if you can't get ATP into the cell, then energy delivery is going to be slowed. If you can't recycle ADP back into the mitochondria, ditto the same. The point being, if we score those processes and multiply them up, we have an objective measure of how well those mitochondria can recycle ATP. And so the next thing I wanted to know is, does that score accord well with the level of disability in those patients? So as a result of that, moving on to the next slide, we did a study. Now, I had 71 patients with whom I'd got stuck. They had done the basic workup. They were doing a good diet. They were on a basic package of supplements. They had worked hard on their sleep, pacing, and we had corrected their thyroid and adrenal function as best I knew how to at that time. Now, the patients and I together, we agreed a disability score. So and we used the Bell disability scale for this. So they decided they were functioning at 30% of what their total ability was, or 60% or whatever. I then took bloods from those patients and sent them off to Acumen to do the mitochondrial function tests. Now Acumen, that's John McLaren-Howard, did the test blind, i.e. he didn't know how disabled the patients were. The results of those tests then went on to a third party, i.e. Dr. Norman Booth of Oxford, of Mansfield College, Oxford, and he worked out the mitochondrial function score. So we then had a clinical score, we had a mitochondrial function score, and we graphed the two scores against each other. And this was published in the International Journal of Clinical and Experimental Medicine in January 2009. Now, the next slide gives you the abstract from that. So if you want a bit more of the science, there you can get the paper. It's online, easily available, but that is the abstract. But this was the most important result that came from that study. As you can see, Norman graphed the clinical score along the bottom, i.e. the chronic fatigue syndrome ability, and the mitochondrial energy score up the side. And as you can see, there's a very close correlation between the two. So those patients who had the worst mitochondrial energy score were indeed the most fatigued, and vice versa. The black dots are the control patients. These were people who were otherwise fit and well, for whom mitochondrial function tests were done. Now, this means we have an objective measure of fatigability. And this has been an incredibly useful tool for assessing the degree of disability and also monitoring recovery. But just remember, you guys, this only pertains to mitochondrial function. I do sometimes see patients who have normal mitochondrial function but are fatigued for other reasons. So this is not a test for chronic fatigue syndrome. It is certainly not a test for ME. It is a test of energy delivery at the cellular level, which is a large part of the condition. Now, mitochondria can go slow for one of two reasons. They can go slow because they are deficient in something. They don't have the raw materials to work. The common deficiencies are low levels of magnesium, low levels of ATP, which can be helped with D-ribose. Vitamin B3, niacinamide, is an essential cofactor. Coenzyme Q10, which I think of as the oil of the engine. Acetyl L-carnitine, which I think of the fuel pipe that delivers fuel, i.e. acetate groups, from the cell into the mitochondria where they are needed, and to a certain extent the need for B12. So it tells us if mitochondria are deficient. And the next slide gives us an idea if there is evidence of blocking, because mitochondria can go slow because they're blocked by something. Of course, I've seen lots of farmers with sheep dick flu who've been poisoned by organophosphates, and guess what? Organophosphates inhibit oxidative phosphorylation. You know, it's no biochemical surprise there. Or mitochondria going slow because the translocator proteins, which are necessary to grab ATP from the mitochondria and flick it into the cell, and then grab ADP from the cell and flick it back into the mitochondria, they may be blocked by something. So that gives a two-pronged approach to management. Now, the problem with Acumen tests is John has been completely overwhelmed. But just because you can't get the test doesn't mean we can't apply these basic principles. And there are tests that can be, nutritional tests that can be done for these things. If you can't get the test for deficiencies, then just take this mitochondrial package of supplements, and the details of what to take are there. Now, I know some people, they have to have magnesium by injection to really kickstart the mitochondria, but I get a lot of success simply from that regime of supplements. And remember that those mitochondrial supplements are over and above what I call a basic package of supplements. Now, because modern diets are so deficient, you could be eating the most perfect diet in the world and you would still be deficient because of modern agriculture. So my view is everybody, doesn't matter how ill or well they are, should be taking a basic multivitamin, some hemp oil, sunshine salt, which is a salt I put together, which is actually delicious. You just use it on your food or when you're cooking as you would use salt, and vitamin C. A good dose of vitamin C for lots of reasons why we should take that. Again, it would be lovely if we could all have access to Acumen tests to do assess toxic stress, but we don't. But Genova do have a useful urine test, which again is accessible to everybody. And that test is a reasonable test of toxic burden, i.e. pesticides, volatile organic compounds, and toxic metals. But to pick up toxic metals, you really need a chelating agent. And because if you simply measure urine for toxic metals, you will get a lot of false negatives. You just will miss many diagnoses. And I tend to use DMSA, which is a very good chelating agent. And you can get that online. It's called Captoma. And you use DMSA at the rate of 15 milligrams per kilogram of body weight. And the point is, with this test, I say we can get a very good assessment of the toxic burden. Now, the question is, having put all these regimes in place, i.e. the nutritional supplements to support mitochondria and the detox regime in order to detoxify them, and remember this is in addition to the paleo-ketogenic diet, in addition to thyroid, adrenal function, all the other things we're doing. The question then is, do these patients get better? And this we published in the same journal in 2013. And the next slide gives us the results. Now, we looked at the energy scores of patients before and after. So the initials at the bottom are not their initials, but just that's how we identify the different patients. And the purple column gives their mitochondrial energy score before, and the orange column gives their mitochondrial energy score after the necessary interventions. And as you can see, the mitochondrial energy scores improved reliably well. Read across, and you come to the last 4 scores where you see the reverse is true. Now, these were 4 patients who, for whatever reason, didn't do the interventions, they didn't take the supplements, or they didn't do the detox regimes, but they came back to me and they wanted to repeat the test. And what's so interesting is in all 4 of those cases, their mitochondrial energy score got worse. The point being here, if you don't put the interventions in, you can expect your mitochondrial function to worsen. Guess what? It's not really surprising that that should be the case. So moving on. The problem is that the patients can't access those tests, but at least we now know from this study that the providing the mitochondria with the raw materials and reducing the toxic stress is a clinically effective intervention. Now, people often ask me what comes up. We can see what commonly inhibits mitochondria. Now, I'm very lucky because Acumen Laboratories do tests on my patients because they have the time to, and I often ask for translocator protein function tests, i.e. what's blocking translocator protein. And what comes up very commonly is lactic acid. Now, as I mentioned earlier, lactic acid will inhibit mitochondria, and this emphasizes the importance of good pacing. If patients are constantly pushing themselves to their limit, then they will never get well. They must pace. It's a little bit like asking a marathon runner to run a marathon every single day. Guess what? His performance drops off. He's going to get worse. Resting and pacing is an essential part of management. What often inhibits mitochondria is part of metabolic syndrome and the fermenting gut. And Acumen, John McLaren Howard gave a wonderful presentation the other day looking at the problems of sugar. And blood sugar levels run high in metabolic syndrome, and that inhibits mitochondria directly. Again, emphasizes the importance of the ketogenic diet. The fermenting gut is an incredibly common problem, and this results, if you're eating sugars and you're eating carbohydrates, then there is a very strong possibility that instead of digesting them, they will be fermented. And when you ferment, you produce all sorts of nasty toxins like D-lactate, like hydrogen sulfide, like alcohol, and they have the potential to cause soggy brains, overwhelm the liver, and inhibit mitochondria directly. Diamino compounds come up frighteningly regularly, and these are dyes essentially typically found in hair dye or food dyes or in pharmaceutical drugs. They often have colorings in them. Parabens come up regularly, which is a widely used disinfectant, for example, in toothpaste or in disinfectant liquids, cleaning liquids. Again, in my view, these substances should not be allowed because they cause biochemical havoc. Malondialdehyde often comes up, which is a symptom of poor antioxidant status. We measure that routinely. Polybrominated biphenyls, which are fire retardants used in soft furnishings. Pesticides. Nickel, again, I had a patient, funny enough, yesterday who had very high levels of nickel on her mitochondria, and getting rid of nickel is going to be an important part of recovery. And nickel is present in jewelry and piercings. It's also present in dental work, dental braces, in stainless steel. So don't use stainless steel for cooking, which is about 14% nickel. Mercury in dental amalgam is also an issue. And then, of course, we can find volatile organic compounds and pesticides. Now, these can all be got rid of using some sort of heating regime, and the details are in chapter 20 of my book. Now, I've now collected figures from over 30 patients who have done some sort of heating regime to get rid of toxic compounds. Now, I don't think it matters what heating regime you use. You could use hot baths, you could use Turkish saunas, you could use sunbathing. Epsom salts in the bath is a lovely treatment. Lots of my patients don't tolerate getting hot, and therefore the far-infrared sauning works very well. But I now have figures from, let's say, 30 patients where we have measured their toxic load before and after these heating regimes. And the bottom line is that the toxic load comes down reliably well. So again, this is a technique that anybody can use. You don't need to go to a special clinic for this treatment. You can all do it at home to reduce your toxic load. When it comes to toxic metals, they don't come out with heating regimes. So my experience is if you've got somebody with mercury poisoning or lead poisoning, the heating regimes don't work. And there are many ways you can get rid of toxic metals. Obviously, identify where they're coming from and avoid those, reduce the absorption of them, and the fermenting gut produces hydrogen sulfide, which greatly enhances your absorption. But there are various techniques there to get rid of those toxic metals. Trace minerals, high-dose vitamin C, iodine, chelating agents, DMSA works reliably well. So anybody, again, can do that. You don't have to go to a doctor. You can sort it out yourself. Next slide. Okay, so having got the mitochondria teed up, we then have to look at the fuel that goes in the tank. Now, the correct fuel for mitochondria is ketones. Not my words, but the words of Dr. Gabriela Segura, who is a consultant cardiologist. Now, she started off her clinical life in conventional cardiology with prescription drugs, pacemakers, surgery, and so on. She now purely uses nutritional medicine to treat her heart patients and gets much better results because you cure the patient. The problem with conventional treatment of heart disease is it slows the rate of decline, but eventually that person's going to die of heart disease. If you treat them from a nutritional point of view, you actually cure the underlying problem. But the preferred fuel for mitochondria are ketones. And there is so much fantastic evidence to demonstrate that's the case. The heart and the brain run at least 25% more efficiently on ketones than blood sugar. Another example I use is that of Mike Morton, who holds the world record for the furthest distance run in 24 hours. Now, he is a keto-adapted athlete. He runs on ketones. And in short, over 24 hours, he ran 172 miles. So ketones are the preferred fuel for mitochondria. Now, I was asked to do another book on this, and the details of this are in Diabetes, which you can buy. But moving on to the next one, essentially, metabolic syndrome. And metabolic syndrome arises when we fuel our body with sugars and starches. That is, I now know, is a major risk factor for chronic fatigue syndrome. And it's the starting point to treat all Western diseases, is the paleo-ketogenic diet. Diabetes is the end result of years of metabolic havoc, of metabolic syndrome. And diabetes, as I'm sure you know, is a risk factor for heart disease, for cancer, and for dementia. And in fact, dementia is now the commonest cause of death in Westerners today. Now, metabolic syndrome has been given all these dreadful names, and my view is these are simply there to confuse patients and make doctors seem clever. The astonishing thing is most doctors don't know what metabolic syndrome is, and I always think that they call it this in order to obfuscate underlying causes. But anyway, essentially, it's when we fuel our body with sugars and starches. Okay, sugar damages the body in many ways. Feeds microbes, so it feeds the fermenting gut, and it feeds infection. Remember, chronic infection is a major risk factor for ME, or is part of ME. Fermenting brain. This is some work done by Nishihara, who's demonstrated if you've got fermenting gut, you've got fermenting brain. And there's potential for neurotransmitters in the brain to be fermented into psychoactive substances like LSD-like substances, like amphetamine-like substances. And indeed, this may be the basis of psychosis. And of course, the starting point for treating any psychotic condition is a ketogenic diet. Again, cancer cells, what makes cancer cells different from human cells is that cancer cells can only run anaerobically. They have to feed on sugar. Sugar in the blood makes the sticky blood, and sticky blood is what damages arteries and nerves. And sugar can stick onto proteins and potentially twist them into prion disorders. And it may be that, we know metabolic syndrome is a major risk factor for prion diseases like Alzheimer's disease and Parkinson's disease. Sugar is inflammatory. It switches on symptoms of inflammation. Sugar inhibits mitochondrial function directly, either because levels are too high or because they're too low. Essentially, it causes metabolic and hormonal havoc. And the ups and downs of the hormones is what makes sugar so addictive. And I illustrate that in the next slide, which I call the blood sugar roller coaster. And as your blood sugars are rising, that gives us the hit, the euphoria, the thrill, if you like. But if blood sugar rises very rapidly, the body knows that sugar is very damaging to it. There is an outpouring of insulin. Insulin shunts the sugar into fat, and then the blood sugar drops precipitously. And as the blood sugar falls, then we get all these other conflicting symptoms, as detailed on this thing: anxiety, fear, panic. Those are all adrenaline symptoms. Now, the brain daren't run out of fuel. And so if blood sugar starts to fall precipitously and that person is not keto adapted, if the blood sugars fall, there is an outpouring of adrenaline, and that causes all the symptoms of falling blood sugar. The brain knows it can be corrected by eating something sweet, and this is what makes sugars and carbohydrates addictive. So as they eat something sweet, then normality is restored, but of course the blood sugar's on the way up again, and the whole cycle reproduces itself. Further problems of blood sugar control which arise in metabolic syndrome or other hormonal disorders. For example, if you've got fermenting gut because you're eating sugars and carbohydrates, one of the products is alcohol. What does alcohol do? Alcohol stimulates insulin directly, and that further upsets blood sugar control. If the thyroid is down, that's a problem because we need thyroid hormones to be able to fat burn, to switch into ketosis. If the adrenal gland isn't working properly because of chronic stress, then again, blood sugar control will be further compromised. All these other issues add to the problem of blood sugar control and emphasizes the need to switch into a ketogenic diet. How do we diagnose metabolic syndrome? It's very easy. Just look in your supermarket trolley. And if it's full of fruit and breakfast cereals and muesli and potatoes and pastry and things, then you are a carbohydrate addict. But when I take a dietary history, I know what the answer is by breakfast, because breakfast, literally, one is breaking the fast of the night. And if people are running on sugars and carbohydrates, then they will be hyperglycemic in the morning. They will have worked that out subconsciously, and they will go for that carbohydrate that gives them the instant hit. So breakfast gives the game away. So if somebody's having fruit juice, cereals, muesli, toast for breakfast, then they have metabolic syndrome. It might be an early form of it, but they have metabolic syndrome. There are some tests that you can do. Glycosylated hemoglobin is a useful test. That is a measure of how much sugar is stuck onto hemoglobin, and that reflects average blood sugars over the preceding 3 months. Triglycerides are often high because insulin shunts sugar into fat, and sugar damages arteries. And if the arteries are damaged, then all our friendly HDL cholesterol is used up in the business of healing and repair. Now, it's important to realize here that cholesterol does not cause arterial disease. Cholesterol levels are a symptom of arterial disease. And it's not the total cholesterol we're looking at, it's the proportion of the friendly HDL cholesterol. People with metabolic syndrome often only have maybe 20% of HDL cholesterol, which tells me their arteries are being damaged. When I have patients on good paleo-ketogenic diets, I expect the HDL cholesterol to be at least 40% of the total. I have a lovely guy who comes to see me who's now 95. He's just won the Queen's Award for Industry, and his HDL cholesterol is 60% of the total. The other very good way to diagnose metabolic syndrome is denial. If people say, oh, no, I don't, or if they rationalize what they take, i.e., oh, well, I need a biscuit halfway through the morning, or I deserve my carbohydrates in the evening, or I need to have a drink, that's another good way to diagnose metabolic syndrome. People make excuses for their diet, and they have rationalized them to themselves. Okay, how to treat metabolic syndrome? And the answer is the paleo-ketogenic diet. Now, because I insist this is a diet that all my patients must do, they then wanted to know what the how of that was. So I came up with the paleo-ketogenic cookbook. And as you can see, the progression of evolution along the top of that cookbook, most of modern Western humans are the penultimate character, with an apple-shaped outline, slurping some horrible drink. He's snacking all the time and eating sweet drinks. And what we need to do is move on a further stage. Why do I advocate a paleo ketogenic diet? Now, whenever I have a difficult question, always ask evolution. And humans evolved over 2.5 million years eating a paleo ketogenic diet. Now, metabolic syndrome has been a very helpful tool to allow primitive man to survive winters. Why? Because during the autumn there would be a carbohydrate bonanza. The fruit trees would ripen, the grains would be harvested, root vegetables would become available, you'd find the odd honey pot. And paleo ketogenic man learned, or maybe it just came up, that he became addicted to those carbohydrates and started to eat them in an addictive way. And in doing so, he gained weight, he got fat. Now, getting fat before a harsh winter is an essential survival tool. It's insulation value, and it keeps us, it's a pantry, it's a fuel supply. So by switching into metabolic syndrome for the autumn and getting addicted, that was important survival value. But the problem now for modern Westerners is we live in a state of permanent autumn, because we can get addictive carbohydrate foods, all the time, cheaply and conveniently. And we never switch off that addiction. Primitive man had to switch off the addiction simply because he ran out of those foods. But now we can eat them all the time. We're in constant metabolic syndrome with all the short-term symptoms of fatness and fatigue, and the long-term complications of heart disease, cancer, and dementia. Now, the difficult bit that everybody struggles with is what I call getting through the metabolic hinterland. Now, if you imagine that I'm sitting in front of my patient, and they are in the land of sugar and carbohydrates, and I'm in the land of fat and fiber, and there's a nasty boggy patch between the two, which I call the metabolic hinterland, and it's a slog getting through it. And it takes, well, at least a week, sometimes 2 weeks, in order to slog your way from one side, from the land of sugar and starches to the land of fat and fiber. Why? Because it's metabolically easier work to burn sugar and starches. The body wants to be in metabolic syndrome because that's let's survive the winter mode. But it's disaster if that is sustained long term. So we have this nasty, tricky patch when we can't get fuel from sugars and starches because we're not eating them. But there's a certain inertia in the system. It takes a little while for the body to switch into fat burning. And so during that time, we have this nasty window when we can't get fuel from either fat or from carbohydrates. You just have to cling on in there. So everybody has to be warned about the metabolic hinterland. So that's what characterizes it: lack of fuel, the temptation to go for instant relief by eating carbohydrates such as banana, but that spikes insulin and you're back in the metabolic hinterland. And so often I see patients who I've given the diet to, I say, yeah, off you go. And they get in touch and they say, oh, I'm still feeling terrible. And I say, are you ketogenic? Oh, yes, I'm doing the diet. Okay, what are you actually eating? And it transpires that something has sneaked in there. They're still having a snack. They're still having a bit of this. They're still having a bit of that. I.e., they've got themselves stuck in the metabolic hinterland because they're eating a little bit of carbohydrates instead of cutting it out ruthlessly. So I had to say, if it takes you a little while to get your head around this, believe me, I was eating slow. I had to work for 35 years, see lots of patients, and write 3 books before I really did it. And, I've done it myself. It is possible. But having got into the land of fat and fiber, I now know this is where I should be for the rest of my life, because I feel well on this diet. My brain is sharp and my body functions as well as can be expected. Now, this is a slide that was published recently. It illustrates the point that the ketogenic diet, we now know, is the central part for the start of treatment, to start treating absolutely everything. It doesn't matter if you've got, there's very strong evidence linking ketogenic diet to all these issues, for weight reduction, diabetes, cardiovascular disease, epilepsy, and the emerging evidence is that it's a highly effective treatment for cancer, for polycystic ovarian disease, for all neurological disease, interestingly for acne. There's a fascinating study which looks at incidence of acne in people living in more primitive conditions. And guess what? The incidence of acne, 0. Guess what? 95% of adolescents suffer from acne, and it all has to do with Western diets. So really, the paleo ketogenic diet is where we start treating everything, including, of course, chronic fatigue syndrome. Now, but it is difficult, I don't doubt for a moment it's difficult, but if I can do it, then so can you. And chapters 2, 3, and 4 detail the bread alternatives, the dairy alternatives, so that your diet can be satisfying and very pleasurable. There's a lovely quote here from David Lloyd George, which illustrates how to get through the metabolic hinterland. Don't be afraid to take a big step if one is indicated. You can't cross a chasm in 2 small jumps. So when people say to me, I want to go into this diet by slowly cutting down the carbohydrates, I can tell them it's not going to work. They will just get into the metabolic hinterland, and there they will get stuck, and they will feel dreadful, and they will get put off, and they won't go the whole hog. So do the whole hog, get the book and do it. Next slide. Now, the absence of bread in the diet is the commonest reason why people struggle with the diet. There's a good joke there which I do recommend you read, and hopefully that will encourage you. But I got it every morning for 6 months and experimented with various seeds and various methods for making bread, and ended up producing something like this. That is my paleo ketogenic bread, and the only ingredients are linseed, water, and salt. And believe you me, it takes just 5 minutes to make. The recipe is in the paleo ketogenic cookbook. There's also a video of me doing my Fanny Craddock act, actually making it in my kitchen. So if you want to see how to make it, then it's there. But the key things you must get right is you have to actually measure the precise amount of linseed and the precise amount of water. You can't just chuck it in and hope for the best. The other thing you have to do is you have to grind the linseed very finely. Now, it's no good buying ground linseed because it's got wet and doesn't perform. You've got to grind it fresh, and then you mix the bread up, mix the linseed, ground linseed with the water, add in the salt, stir it around vigorously, and it forms a dough. And then you fashion it into a shape, put it into a very hot oven, and you get that loaf. Chapter 4 is all about the dairy alternatives. Now, dairy products are not evolutionarily correct foods. When Corday and Lorraine was asked, aren't dairy products natural foods, his response to that was, have you ever tried milking a wild bison? And dairy products are the cause of many chronic diseases. They're major, first of all, it's a major antigen. About 30% of the population will be allergic. Lactose intolerance is common, and many, if you're lactose intolerant, then you will start fermenting milk instead of digesting it. Dairy products are growth promoters, and we know that they're a risk factor for cancer. And I do recommend you read Jane Plant's book, Your Life in Your Hand. They increase the risk of autoimmunity. They increase the risk of osteoporosis. Having dairy products makes it more likely that you're going to get osteoporosis. They're a major risk factor for heart disease because they make the sticky blood. But the PK cookbook has lots of wonderful alternatives which are just as good, and there's coconut milk there called Grace coconut milk, which is absolutely excellent. It's like drinking single cream. There's also a chapter which I call about salt, sunshine salt, and people who are doing a ketogenic diet need more salt than otherwise. It's an essential part of our diet. But what I have done is I've put together a salt which is 80% sea salt. In fact, it's Malden sea salt. And it contains all other essential minerals. And the reason we need this is because of mineral depletion in the soil. So these are figures from the US Department of Agriculture. In 1910, soil had 500 parts per million. 2006, less than 50 parts per million. And believe you me, it'll be worse now. So you could be eating the most perfect organic diet, and you would still be deficient. And I hope the next slide will show us, you can't see that very well, I'm afraid, sorry about that, but this gives us the constituents of sunshine salt. But as you can see, it's got all the calcium, magnesium, potassium, zinc, iron, boron, iodine, manganese, etc., 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 that you need, together with a really good dose of vitamin D3, because everybody is deficient, and vitamin B12 because everybody is deficient. And interestingly, both vitamin D and vitamin B12 are heat stable. So I put this routinely in my bread. It survives heat perfectly well. So we can eat extremely nutritious bread. Now, the next thing is, have we got any questions? I have detailed the importance of mitochondrial issue, which is the engine of our car, and the fuel that must go in the tank, which is the ketogenic diet, which cuts out gluten, grains, and dairy, of course. So I think that I've covered those subjects that I was asked to cover. So if anybody comes back to me with some questions, then fire away and I will pick up on those. There's another website I set up called Natural Health Worldwide. And it's a website where any patient can access any practitioner and also any test. So if you want to get any of these tests from Genova or Biolab or Armin Laboratories, or you want to access a practitioner, it might be a doctor, it might be an osteopath or an acupuncturist or herbalist, or it might be an experienced patient, i.e. somebody who's got experience of treating ME or whatever, then they can access them directly online. And the idea is that the website books the appointments, and the website takes the money, and then after the consultation the patient can feed back to the website to say that was a great consultation or that was a waste of time or whatever, so that the practitioners can then build a reputation and develop a business online. But thank you for your attention.